Remember to record. Sweet. Oh, can't minimize it. Okay. Go here. Boom. Bam. Okay. So let's start here. So this is 1.2. Finished up 1.1. And we are going to review super, super fast in one single day, all of like chapter one of Algebra 1 kind of thing. That's what we're going to do. What? So, or Algebra 2, sorry. So the rectangular coordinate system. So the question is, who made the rectangular coordinate system? Rene Descartes. He's also the guy that said, I think, therefore, I am. Absolutely. So, and that has a whole history behind it as well, which is pretty cool. Next is this. So when did he discover it? And what happened beforehand? So back to your geometry days. Do you guys remember doing straight edge? And did you ever do compass? Like, okay. So that is geometry, and that is geometry from the Greek era. We're good? They can measure stuff, but for the most part, abstract geometry was, can you do a segment divided by two? Yes, you can. You did it by doing a compass, right? On one side, doing another, and then putting a line down, right? Like, hey, I got it by divided by two. Rene Descartes comes along, and in fact, it was a fun little thing that happened here. He woke up on a Saturday morning, and he looked at the ceiling, and there was a fly on the ceiling. And he said to himself, if I have a person that came in here, how could I tell him exactly where the fly was? Good. So he just had this idea. How about if I go from the corner of the wall or the corner of the room and I designate like inches up, right? And inches this way. And it sounds to us like that's so simple, Mr. Ngiev, right? But like, it takes the first person to do it, then everybody's like, oh, well, that's easy, right? So geometry was geometry and algebra was algebra. You solve stuff. But those two could never be united because those are two separate fields. We good? So Rene Descartes, by having a fly on the ceiling, merged geometry and algebra together for the first time. So when you draw this line, right, and you get a midpoint of a line, aren't you doing a bisector of a line? Right, so that's exactly. So he fused algebra, geometry. Algebra and geometry finally became one. We good? So let's go with it here. So X and Y coordinate system. This little guy right here is called the origin. This is the X-axis. That's the Y-axis. You guys know. We good? And then these guys are just quadrants. So quadrant one, written always in Roman numerals. That is when the X and Y coordinates are both positive. Quadrant two is when the X coordinate is negative, Y coordinate's positive, and we go on from there. Quadrant three is when both of them are negative. Quadrant four is when the X is positive and the Y is negative. Are we good? So when we get into trigonometry, I'll say the angle is in quadrant four. And because of that, you should like, oh yeah, because that's true and that's true. Essentially, what's true? The X is positive and the Y is negative. Okay. Okay, let's jam. So no need to copy this one, but I just want to say what we're going to do. We're going to graph lines. We're going to graph parabolas. We good? We're going to use the distance formula. We're going to graph circles, and we're going to finally put angle measurements together. We good? Let's jam. Can you guys graph this guy for me, if you remember? If you remember how to do that. Okay, don't graph it for me. Graph it for yourself. All right, I give you a little hints here. So this guy is the same thing as mx plus b. Is that right? And then the b is missing. So what we do is for the b, we just put a zero for the b. We good? It's all yours there. Can you graph it? And this is the time you can actually, after you finish your work, you can kind of look at the person's next to you to see if you guys got the same thing. Just during test days. Those are not good to do that during test days. Yes, yeah. Cool. You can graph it in a calculator as well. Yeah, but I do want you guys to graph it by hand. Oh. Oh. No, no problem, no problem. Okay, let's jam with it here. So if B is 0, everybody okay with? That starts at the origin. And then we are going to go up 3, and we're going to go over to the right 4, and we're all good to go. So let's go with it here. This is also, B is also the y-intercept. I know it's basic stuff. I know we're reviewing. That's all. Just getting our mind around it. There it is. That little dot right there is where we start because B is 0. Therefore, along the y-axis, we find the 0 number. From that little guy right there, all we do is we're going to go up 3 and 4 to the right to give us our next point. Are we good there? And from geometry, we know that we just need 2 points to determine a unique line. We are good to go right there. Don't forget to put arrows at the end because lines keep on going and going and going. Line segments, they stop, but lines keep on going and going and going. Out of curiosity, anything else that keeps on going and going and going? Life keeps on going. Okay. Life. Infinity keeps on going on there. So you guys are too young. There's 1980s, 1990s. There was the Energizer battery. They had this commercial, right? It was called the Energizer Bunny. This little bunny that would just run through the commercial. There's like a big commercial about something else, right? The Energizer Bunny would kind of come in, you would turn around and show the Duracell battery in the back, right? And then it just kind of kept on going. And the commercial always goes like, and the bunny keeps on going and going and going and going. And that was it. That was it. That was the
original
Energizer.
The original one was the Duracell, and then Energizer took it from them.
Oh yes, okay, yeah.
And then now Duracell is the one that does those advertisements.
Oh, interesting.
Energizer does in the US.
Mm-hmm. Oh, interesting. Okay, I have to look that up. That's cool.
They like swamp places.
Mm-hmm. Copyright ran out on it, so whoever wants to take it now.
Yeah, similar.
True. All right, let's go with it. Now this one's a little more difficult. Let's go with, can you guys graph for me a parabola? Now parabola, let's do the formula for it first here. That's a parabola, and that's a parabola that is in graph form because there's something about h and k that's very, very important. So first things first, if you're to graph this guy, you go like this. Remember, parabolas go down and up or up and down, whatever, right? Don't make it a V shape. It's not a V shape, right? It doesn't go down and hits a corner, goes up. It goes down and kind of goes down to a little bottom here, then comes back up. First things first, that little guy right there, that is called the vertex. And the vertex is H and K. Now, what's weird about H? It's the x coordinate, Notice in the formula H is a negative. Is that right? So for H, it's always the opposite of what H is. So if it was a -3, the vertex would be 3. We're good for H. And it's a positive K on this side, so therefore whatever this guy is here. So it's the opposite of H, and then whatever K is. And we'll do this like the fast way. I don't think we teach this in Algebra 2 for parabolas, because we teach it by doing points and then connecting them together. Is that right? And then by transformations. But this one is a quick way. So here's what it is. If we know the vertex, we're great. We also need to know the direction. So if it's going up, the A value in front is greater than 0. It's positive. It's A is positive. We get a graph that looks like this. If A is negative, where do we go? We go down. So there it is. We have direction and we have vertex. That's all we kind of really need. And the only thing is just how fast it goes up or how fast it goes down is still determined by A. So let's do this one together. All right, and watching my time here. Okay, and then again, tell me if I'm going too fast. If I switch this side, like, Mr. G, if you're going too fast, just raise your hand. I'll know what that means, and I'll go back. But I'll let you guys try it here. All yours here. Exercise 2. Can you graph this little guy right here? Actually, let's do it together because it gets more complicated. But can you find the vertex first? There it is, and then I'll let you guys at least get to that point.
Wow. I don't know what it was, but I think it was one word. You just like,
Oh,
That's so like birds.
I I hear like a little tick of the
Think, yeah, think. Uh-huh.
There was something.
I heard like a squeaking. There's some sort of squeaking sound, like something was being dragged across
Oh,
like
gosh.
glass or
Uh-huh.
something.
Okay. Interesting.
Poor bird.
Mm-hmm. And then also whatever you guys are comfortable with here. I see some people have just note paper with just straight lines across, right? That's cool too. Some people have grid paper, whatever you feel comfortable with doing, right? We are going to be graphing quite a bit and stuff like that. So if you ever want to switch to grid paper or quad rule paper as it's called, that's cool.
We'll be graphing for 4 years and stuff.
Chapter 4 a lot. So that for chapter 4 probably be good to if you do line paper to switch to grid paper. All right, so you guys tell me, where is the vertex? 3, 4, 1, 2, 3, 1, 2, 3, 4 up. That guy right there is this parabola going up or down? Up. Okay, so now here's a little thing right here. Here's what we do with parabolas. It's just like the fastest way to graph parabolas. We are in this little part right here. What we're going to do is we're going to go 1 to the right. Good. And whatever we go off to the right, we square that number. So 1 to the right, what's 1 squared? 1. Right, so what we do is right here, we go, technically, let me just write, if we go 1 off to the right, we square that 1, we get ourselves to go up 1. We good? And that is going to be our next point right here. So our next point is 4, 5, is that right? So then what we do is we go 2 off to the right. 2 squared is 4. So we're going to go 4 up. So one more, we'll go 2 to the right. We square that number, and we're going to go 4 up from 4, which would go up to 8. Are we good? 8 units up higher, we are right here. See if that makes sense, because I don't think we've... Cool, cool. How about this here? Thumbs up if it made sense. Thumbs sideways if it's like, what are we talking about? Okay, gotcha. Okay, so let me go back real quick here. Let me go back. Just do it one more time. So we're trying to figure out the curvature of how fast is it going up. We good? So we're going to get the curvature pretty easily done. So think about this here. We already started at 4, is that right? So the only change that happens is this right here. So if I plug in a 4, we're starting at 3, right? 3 is our... If I move away from 3, if I move one row away or 1 unit value away, 4 minus 3 is 1. Square the 1. 1. And we're already at 4, right? So that means we just added 1 to our height. We good? But notice what happens if we do 5. 5 minus 3 is 2. Then we'll square that 2. Now we're at, now we're at 4 away from our height, right? So this little number here determines how fast we move. So if we move 1 to the right, we move 1 up because it's squared. Are we good? We move 2. Now we square the 2. Now we're moving up 4 units. Are we good? 4 units away from 4, which is 12 now. Out of curiosity here, if I go out to 3, if I go 3 units away, how much should I go up? 9. And notice just by doing that, I get myself the curvature that I need. Good? All right, from geometry though, and from algebra 2, we know that parabolas are symmetric. Is that right? So whatever I do to the right side, now I can do to the left. So if I go 1 to the left, I go 1 up, and there's my other dot. If I go 2 away, I just have to go up 4. If I go 3 away, I got to go up 9. We're good? So it's the square of how fast you go away. All right, once you get those dots in there about-ish, make a little parabola. Don't forget to put arrows at the end. Okay, and let's jam. Are we good? And of course it gets more difficult. That's the fun part about mathematics. So let's go with it here. And again, tell me if I'm going too fast. See some people still writing stuff down. Cool. All right, this one. Let's go with this one. Can we graph this guy? Now what we do is we have a little 2 in front now. And I'm going to do it together with you guys here just because of time's sake. We have about 20 more minutes here. So I'm going to go with this one here. You guys tell me where the vertex. What's the vertex? 3, -5. Boom, 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 boom. I got myself my little dot right there. Cool. Now notice, what's my A value? It's 2, so it's bigger than 1. I'm sorry, bigger than 0, right? It's positive. We're going to go up. But now here's the little problem. It wasn't 1. Last time it was 1. Is that right? So here it is. Here's what we're going to do. Check this out here. If we move over to the right 1 unit, we're going to go up how much? We're going to do 1 squared, right? But then we got a multiplier of 2. Let's see if this works. If we go out to 4, this is a 4 now, right? What's 4 minus 3? 1. Square of 1? That's still a 1, right? But then we got to multiply the A value as well. We good? So this guy becomes a multiplier after you square your term. So 1 away, square the 1, 1. And then you got to still do the multiplier of 2. So we're going to go up 2 units. We good? So it's A times the square of what you move away from. Okay, you guys talk to me now. If I move 2 units away, in this case, we had to move 2 units up.
8.
Everybody okay with 8? We move 2 units over to the right, right? Squaring the 2 becomes 4, right? And then doubling that because of the A equals 2. So now we're going to go up 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. Are we good? We're all the way up to here on our next term. You guys talk to me. Does that make sense? All right, let's go with this one here. So thumbs up if it doesn't make sense. Thumb sideways if you're still struggling with it a bit. Cool. Okay. And so let me just do this last one just to make sure we got it here, because we've got a couple of just a few people here still. So if you move 2 away, we do the same thing that we did last time. We square the 2 makes 4, right? So technically we would go up 4 units like we did last time, except that little multiplier of 2 over here means we're going to go up even, we're going to go double that. So that little 2 here, instead of just squaring something, we double it at the end. So just out of curiosity here, if I were to go out 3 units, 3 units would be, squaring 3 would be 9, is that right? 9 times 2, 18. We would go 18 units up higher. Okay, by that time, we're off the graph, so forget that. We're good? So let's go the symmetry stuff. So whatever we do on the right-hand side, we're going to do on the left-hand side. So if we go up 1 over to the left 1 unit, we're going to go 2 units up. If we go 2 units to the left, we're going to go now 8 units up. Okay, and that is probably the fastest kind of rough graph way we know how to graph parabolas. We good? Except they have to be in this form. This is called the graph form of parabolas right here. Okay, I know I'm jamming, but that's parabolas. We good? Let's go to distance formula. So we got to draw it too, all right? Draw it, put arrows at the end. And notice this one, if you were to graph them and look at them side by side, this one's just skinnier, right? Because it goes up faster. It's going up twice as fast. Okay, jamming with time. Here it is. The distance formula. There it is. It is x2 minus x1 squared plus y2 minus y1 squared. Cool. All right. I'm going to just jam real quick here just to get us to where we need to be here. So exercise 4, find the distance between the 2 points, 4, 7, and 8, 1. So if you want to, you can graph it, but you really don't need to graph it. I just kind of showed it as a graph here. We're just going to use the distance formula. So no need to graph it. I just want to show the visual for it here. So 4, 7 would be about right here. And 8, 1 would be about right there. So I need to know the distance of that line right there. And again, don't graph it, just use the formula for it. So I didn't put any negative numbers in here. So kind of careful when you do negative numbers. I assume you guys can do negative numbers thoughtfully here. So here it is. I got myself my x2, which is 8, minus my x1, which is 4. We're going to square it, add it with, taking the y2, which is 1, subtract the 7, which is y1. Y2, yeah, y1. Okay. And I got myself 8 minus 4 is 4. We're going to square that guy. And then 1 minus 7 is a negative 6. We're going to square that guy. And how about the square root of 16 plus 36? Which would make square root of 52. And now the question is this, does that reduce? Can I break down 52 and are there any perfect squares inside it?
Yes.
Okay, yeah, 52 breaks down into 2 and 26. I figure it's an even number. I can at least get 2 out of it, right? 26 is also even number, so perfect. Okay, so it'd be 4, technically it'd be 2 squared root of 13, right?
Oh, yeah, so
So then we have ourselves, there are doubles of 2s. There's my 4, so square root of 4 is 2. So how about a 2 on the outside, 13 on the inside? Okay, still jamming. All right, that's the distance formula. The next thing, bless you. Again, we're doing all of chapter 1 of Algebra 2 in a single day. Good? Not in a single day, in like 36 minutes. Okay, so that's the distance formula. Try it on the homework. That's what we'll be at. We good? Next is the circle formula. We'll be using circles a lot. But if I have a circle like this, the middle of the circle, hey, I'm going to label H and K again. All right, and then the points on the outside of a circle are X and Y. And it really just covers it's really just the distance formula, isn't it? So don't need to copy me on this one, just copying down the last piece here. But if we did the formula, so don't need to copy what I'm going to do right here. So if it was the distance formula, we would have something that looks like this. Is that right? 0.1, 0.2? So this would be h minus, if that was 0.2 and that was 0.1, it would be x minus h squared, y minus k squared. And all we do is we just square both sides. So the circle is really just the distance formula in disguise. All right, what do you want to write down is this right here. Turn it around. This last one is the one you want to write down. Here's our distance formula. X minus h, I'm sorry, our circle formula. X minus h to the second power plus y minus k to the second power is equal to r to the second power. All right, guys, I know I'm speeding, a little bit speeding here, just to finish up here. All right, we're not going to really draw. We're not going to go from equation to circle, but I just want to verify something on the homework here. You guys will have another point here. Can you guys do this? Can you verify that that point right here actually is on the circle? So a lot of stuff. Sorry, there's more. So verify, my chicken scratch here, verify that negative square root of 3 over 2 and a negative 1/2. Hey guys, isn't that a 30, 60, 90 triangle that we formed? Interesting. Okay. Verify that that point are points that lie on a circle of radius 1 and the center being the origin. So where's my center of my circle? 0, 0, is that right? So my H is 0, my K is 0, right? And we just want to verify. Verify just means you plug everything in, make sure that algebraically it makes sense. That's what we do with verify. So let's plug in. So H and K are both 0, 0. Let's plug into the formula that we know. So let me just rewrite it out here so we have it. X minus H to the second, Y minus K to the second is R squared. So really, H and K are zeros. I'm going to forget about them completely. So then I'm going to just plug in X being a negative. So there it is. That's my equation at the origin, right? H and K go 0. Let's plug in negative root 3 over 2. We're going to square this guy. Negative 1/2, we're going to square this guy and see if it's going to turn out to be same thing as 1 squared. All right, you all, what is negative root 3 over 2 squared? So first things first, negative times a negative? Positive. What's root 3 times root 3? Just 3. What is 2 times 2? 4. That's cool. Okay, plus. Again, negative times a negative. Yep, 1 times 1. 2 times 2. And the question is 3/4 plus 1/4, does that give you a 1? Yes, cool. Okay. We just verified our 30, 60, 90 triangle is correct. We good? And it forms that triangle. Okay, cool. So now let's do this here. So Ptolemy, Saturday morning, nothing to do. He was like, okay, so Rene Descartes, he fuses geometry and algebra together, right? And so Ptolemy sits there and he says to himself, don't need to draw the circle here. Here's what I want you guys to, it's called angles and standard position. He has this brilliant idea. Oh, I have this X and Y grid that Rene Descartes made. That's cool. What if I get my X and Y grid and all I do is I put a angle inside here? I'm going to use that guy as my vertex, the X positive axis as my initial side. Remember initial side from 1.1? And then what I'm going to do is I'm going to end it somewhere. It doesn't matter where it ends. I'm going to call this my terminal side, and I'm going to label an angle there. Cool. And hence trigonometry just got started, just because of that small, fun little idea. And so now let's go with the small, fun idea here. It's kind of cool how ideas are just born. It's like I was listening to another broadcast the other day. It's like just for the fun of it here, like Tolkien, right? He writes a series of books, right? But before Tolkien, there was nothing. We didn't think about Middle Earth. We didn't think about all that, right? So it was non-existent, right? So this guy in his own brain thinks like, this would be so cool to actually develop my own language, and from that language develop a whole storyline, right? Because he developed his own language in the book. So that's kind of cool.
That's the real language.
Yes, yeah. He studied ancient Druid languages. That's what he was a professor of. And so instead of like Greek or Egyptian, he studied the northern Ireland, Scotland, and the Druids. And from there, he synthesized the grammar of it. Once he synthesized the grammar of it, he made his own language based upon that grammar. So cool. Okay, guys, ready? And let's go with it here. So let's do what Ptolemy did on a Saturday morning. He said, I'm going to draw this. I'm going to draw this standard position. And what does a negative 60-degree angle look like in negative position? So I got myself my X and Y grid as before, and 300 degrees and negative 45, 140, 50 degrees here. So X and Y grid. My initial side has to be here. So notice I'm going to put a little arrow to the positive x-axis, and it's a negative angle. Which way am I going to go? Down about 60 degrees. So it's not halfway. Halfway would be 45 degrees. So maybe just go just a little bit more than half, like about there. And then don't forget to put that little guy in there, right? This little guy right here. Chunk, chunk, chunk. And then because we know what the degree value is, we don't put theta. We actually put negative 60 degrees. There it is. We have drawn an angle and fused upon an X and Y grid, and we've just made trigonometry. Oh, okay, hold on. How about this here? How about 300 degrees? What would that look like? Still, yep, still standard position. Don't forget that, right? It's positive now, so we're going to go against the clock, and we're going to go 300 degrees. So if we go 300 degrees, aren't we like 60 degrees shy of 360? Hold on. So then which way did we go again? Against the clock? Yeah, so we got to show that. We got to show that right there, draw it in. And we do have to label it. So label somewhere along that little curve arrow, you label 300 degrees. And then real quick here, aren't those in the same exact position? Okay, so here it is. What we're going to do is we're going to call these guys coterminal angles. Coterminal angle means I don't care what the degrees are, they just land in the same spot. Cool. And then for yours, can you do that last one there? Where would be 450 degrees?
Swung around into non-existence.
Could be. Negative
Does
400.
it go around? Does it not work? Or does it go around one revolution?
Okay, yeah, so we have one revolution went around. So we went around negative 360, right? And then how many more degrees do we need to go now? 90. Okay, so let's see. So that means it lands actually down here. Is that right? But then we do have to do that curvature arrow. How did the curvature arrow goes? We went clockwise, right? We went like that, right? We actually have to show how many times we went around. If we went around 10 times, guess what? We have
Oh no.
10 times that we went around.
I remember what you're talking about now. I remember Miles telling me about this.
Oh, okay, cool, cool. Uh-huh.
I'm scared.
No, you're all good. So you get a label degree somewhere. It's negative 450. Is that coterminal with the others or no? No, not
No.
coterminal. Okay, 1 minute left. Let's jam. And one last problem to go. So let's tweak our brains just a little bit here. Instead of starting with the let's just go one more crazy one here. Okay, but we do have a special name for this guy. Notice it ended on one of the axes, right? So if it ends on one of the axes, it is called a quadrantal angle. Quadrantal angle, it's QU, don't mind my chicken scratch, QUADRANTAL. Whole bunch of A's in there. Quadrantal angle. Because it's sitting, the terminal side is on one of the axes. All right, and one more problem. Let's go. Let's put it all together here. Exercise 7. So name a point on the terminal sign, find the distance from the origin, and then name another angle that's coterminal. Just one minute, we'll be done here. So, whoa, okay. So we got to think about where this point ends. We're at 225 degrees. So on the homework, the back of the book may choose another point for these problems, so you may not get the same answers. We're good? So kind of careful with this one on the homework. So let's go with it. You guys tell me which quadrant is 225 degrees going to land in?
It's easily quadrant.
Quadrant 3, right? That's 90, that's 180, right? But it's not far. That's 270. That's a little too far. So it's about right here. 225 degrees. Oh, isn't it a 45-degree angle? So what do you guys know about a 45-degree angle if we go this way? What would be the points that are along that line?
Negative one.
Oh, y and x are going to be the same. Is that right? Because it's like right in the middle of the. So you could choose for the homework, you can choose -4, -4. You could choose -8, -8. You could choose -1, -1. We good? So when you name that terminal point, it doesn't matter which one you choose. I just choose -4, -4. We're good? Okay. And then from there, we just find the distance. I'm going to do it real quick here because we're out of time. Ready? Just for you guys to see it. Ready? If I chose that point, now the book chooses -1, -1, or it could have chosen -2, -2, right? So your points are going to be different here. I'm going to choose -4, -4. I'm going to use the distance formula. The distance formula gives me, what do you know? 4 root 2. Anybody know about 4 root 2? Something about 45, 45, 90 triangle stuff? I don't know. Weird stuff. And then, can you guys give me, real quick here as we finish, can you guys give me another coterminal angle? To 225. Ooh, Ian says -135. Everybody agreed? If you go this way, it'll be 90 plus another 45. So coterminal angle to 225, -135. Or what I can do is I can take 225 and add 360. Would that give it to me? So 585 is a coterminal angle, or -135 is a coterminal angle. There's a whole bunch of them. We are done.
Homework. Please play 1.2.
So 1.2, yep. I kind of pushed to get to the end here. So we'll slow down. We'll take a little bit of time.
What will we do Friday?
Friday of next week. Yes, absolutely. So we'll take Wednesday to go over any homework questions from 1.2, and then they'll be officially due on Friday of next week.
Thank you.
You too. Thank you so much.